Does it work? Oh, it does. Wow, aggressive. All right, so today's going to be a little bit different. So we're going to do some live coding, so please be prepared for that. But as the slide says, I'm going to be talking about resilient e-commerce on Kubernetes. So does it work? Oh, that's a button. That one. Got it. There's a laser pointer. Cool. All right. So real quick, who am I? My name is Damien Retzinger. I am the founder of a little agency called Graycore. We do a lot of open source work. I am a Magento contributor. I've been a contributor since 2015. I'm one of the maintainers of MageOS. If you're familiar with it, you can look it up. I'm also the maintainer of a PWA for e-commerce called Daffodil. It's in Angular. And then I'm also one of the maintainers of Faker.js. So if you're familiar with the Faker JavaScript library, I'm one of the maintainers of that. But today's talk is about very few of those things. Mostly we're going to be talking about Kubernetes. So just kind of a show of hands, who knows what Kubernetes is? All right, we got a couple. All right. So real quick, Kubernetes is a open source container orchestration system. It allows you to automate large scale deployments of software very quickly. So you can do crazy complicated deployments. You can do specialized servers for, like, maybe this is an application that requires more memory. This one requires more CPU. Allows you to do those kinds of things. But yeah, you can scale, deploy, manage large deployments. So we're going to eventually get to the point where we talk about that and its relationship to Magento. So real quick brief history on Kubernetes. Kubernetes was started in 2013. Google internally had a system called Borg. Borg was a container orchestration platform. Eric Brewer and some of the engineering team decided we need to take this from only internally at Google to the open source space. So Brendan Burns, Craig McLuckie, and Joe Beta convinced the executive team at Google to open source Borg 2.0, which became Kubernetes. It is importantly open source, so if you want to contribute to Kubernetes, you can, just like you can to Magento. And it's currently maintained, though it was developed by Google, it's currently maintained through the CNCF, which is the Cloud Native Computing Foundation. It's a graduated project, which means it's mature, it's maintainable, it's well established in the Cloud Native Computing ecosystem. I link there the CNCF project, so if you want to go look that up, you can. And then additionally, the GitHub project if you want to contribute. So Kubernetes is a cool term, and the prior slide is kind of interesting. But what does it mean? So if you know what this is, if you know what this picture is from, let me know. I'll send you a t-shirt. But as I said, it's an open source container orchestration system. So I kind of want to break that down a little bit, and we'll get into kind of what those individual terms mean. So the first one is open source. I think we're probably all familiar with what that term means. But if you're not, just means that the code is accessible and you can contribute to it. So you can go submit a pull request to Kubernetes and make your changes if you find something you want to change. It's a container orchestration system, so it leverages Docker containers. It doesn't necessarily have to be Docker, but any kind of OCI container would actually work. So if you're familiar with the OCI specification, you're not obligated to use Docker. Docker is just one implementation of the container specification. It's an orchestration system, so it allows you to orchestrate many containers. So instead of just thinking about like your Docker Compose environment where you have like one or two containers and maybe you have several containers, it allows you to do many, many, many containers. And importantly, it's about automation, right? So you automate your deployment, you automate your scaling, you automate your management. So in a little bit, we'll get into some examples, but you automate deployments. So Kubernetes is a declarative language for deploying software. You just simply say, I want to deploy this container. And you then run it. And then you forget about the rest of it. That's a really powerful concept. If you're familiar with Linux administration, you can imagine in your LAMP stack, you have to manage the deployments. You maybe have to go do a git pull somewhere, maybe run a make file. You don't really have to think about that so much. It's just you say, I want to deploy this container there, and you're away to the races. In terms of scalability, Kubernetes has some built-in mechanisms for managing auto-scaling. So you can define metrics which decide, should this container scale from 1 to 2, 2 to 3, 3 to 4, so on and so forth. Out of the box, it comes with two. One is for memory management. One is for CPU utilization. So you can say, for example, if CPU in this container goes above 50%, please give me another copy so that you can reduce it by half, right? Or you can say, okay, if it goes up to 99%, give me 4, right? Bringing you down. And finally, management. No particular software platform, Magento is no exception, is frozen as soon as it's done. Like it doesn't stop working. So you have to go from update to update to update. And over its life cycle, you need to be able to do management of that piece of software. Kubernetes is a fantastic tool for automating large-scale deployments. So if we're talking like 1 or 2 servers, maybe management's not so bad. But once you're doing large-scale deployments with hundreds of servers, even in thousands of servers, Kubernetes becomes very, very helpful. All right, so if everything works, we're going to do a little toy application here. And it's going to be a little toy Kubernetes application. So with any luck, I can log in here and we can see this. So if you just want to switch to my screen, we're going to showcase a little Kubernetes application. So I'm going to showcase 2 things. The first is just this little toy application. The toy application, I'll kind of walk you through some of the things that are within the application and hopefully might feel familiar to you if you've done LAMP stack deployments before. But the first thing that we're going to look at here is going to feel very familiar to your Docker Compose files if you're familiar with Docker. It's a PHP Apache application. It has some labels associated with it, and ultimately you have a container. So a pod at the top. So at the top of your line 2, you see the kind. Kind is a deployment. A deployment is a logical unit of a application. So your application is a deployment. A deployment contains many pods, and a pod contains many containers. But in this case, you can just kind of think of this as I'm deploying one PHP container. The container name that I have here is called PHP Apache. The image here is a registry.k8s.io. If you don't know, K8s is just the shortening of Kubernetes, just removing 8 words in the center. And the example name, or the example container here is the horizontal pod autoscaler, or HPA example. This is directly from the Kubernetes documentation. If you want the link is actually here at the top of my screen. If you want to take a screenshot, you can find that. Or you can just Google horizontal pod autoscaler in the Kubernetes docs. You can specify some ports. As I said, you can specify limits, CPU limits and requests. So these are just features of Kubernetes. Basically, that means I would like to allocate 100, or in this case, allocate 500 millicores of CPU. So maybe Magento needs 4 cores. You might say, please allocate 4 cores of CPU to this Magento application. That's what the request is. And the limit is how much can this container use? So if you're running Magento in a large cluster and you have hundreds of servers, you might want to say, okay, well, this individual instance of Magento can use only 4 cores. So maybe I request 4 cores and I say, okay, maximally you can use 4. If you don't set a limit, Magento or that particular those PHP FPM processes that are on that container can go up to as many cores as they would like. So you could very quickly get up to 60 cores of CPU if you really didn't control it. So those are just interesting settings. Other things here, horizontal pod autoscalers. As I said, it's a way to autoscale your application. So you can specify, so for example, this one, we specified that if the average CPU utilization goes above 50%, please give me another container. And we specify a minimum and a maximum. How many do we actually want? So we want a min of 1, so min replicas here at the bottom. Min of 1, max of 5, max is up here at the top. Notably, this is just a YAML, so you can change the key names around in whatever order you like. It doesn't really matter. And then finally, the service. So service is just like a logical load balancing thing in Kubernetes. It just says, okay, this is a layer above the actual container deployments. When I call this service, please hand off requests to my underlying containers. So I have a running Kubernetes cluster here. I'll just showcase a couple things. So kubectl is the developer-facing command line for Kubernetes. I have an alias in my bash here for K8s, just because I like that and it's shorter. But so if you see me type K8s, please just know that I'm running kubectl. So kubectl has a lot of different commands in it, but importantly, I just kind of want to show what it looks like if you have a Kubernetes application. So what I'm going to do is actually just apply this entire folder of YAML files. So you can see I just said, please apply these specifications, and all of a sudden, Kubernetes will start doing its thing. So right now what we're going to do is we're going to create a deployment, we're going to create a horizontal pod autoscaler, and then we're going to create a service. You can run k8s get and then the application kind. So if you want to get like what pods are running in this cluster, you can get the pods that are running. And you can see here, for example, I have a PHP Apache pod. So I can, mostly what I want to showcase here is like auto scaling. So I'm going to showcase applying load against the cluster, but I'll just showcase a couple other commands. So there's a get services commands. When you create a service, you can create it with a bunch of different kinds. One of those kinds is a load balancer. Depending upon your infrastructure as a service provider, by creating that load balancer, it's actually going to get allocated an IP address. So if you're bored, you can actually go look at this IP address and you can see the little cluster, or little application that I have running. It's just going to say OK on a white screen, but you can go see it if you'd like. Notably, however, you can apply load. So for example, I have a little command here, which is essentially just running a wget a lot. And it's going to start to apply load against the pods. And I'm going to leave that running. You can see what it's doing. It's just returning whatever I get back from the server. So it's just returning the string OK. And I'm going to showcase what happens in a cluster when you do this. So I'm going to look at k8s, get pods. I'm going to leave that there. And I'm going to leave a watch. Oops, wrong command. Watch doesn't know about aliases, so kubectl. We're going to leave that running for a second. But what you're going to start to see is as the server has load applied, so you can imagine it's Black Friday and you're at home, maybe you're with your family, you don't want to be managing the deployment on Black Friday, and you get an alert. There's a lot of people on the site, right? So you want your stuff to auto scale. You want it to handle it for you. You don't want to think about it. What you're going to start to see is that the application will start to scale. Now, there are all sorts of configurations about, how long does it take to scale? And you can see it's already done it. How long does it take to scale? How long does it take to process? How fast does it start to tear down requests? And you can start to see that we basically just quadrupled our total available application handling. So how much we can actually do. So this is going to continue to apply load until I stop it. But once I stop it, eventually the cluster will start to scale itself back down. So we auto-scaled up as load came in, as we started to consume CPU, and now over time it will start to scale these back down. So you'll see that the Apache containers start to go back down to 1. So that's a little mini Kubernetes application. As I said, it's just a simple PHP application, but you could replace the container with container of choice. It can be a Node.js container. It could be if you use Go, you can use Go. If you use Rust, you can use Rust. If you use .NET, technically you can actually do .NET containers now. So if we want to go back to the slides. Maybe? Yeah, perfect. So I showcased a little Kubernetes application. We saw that it was declarative. You define some settings, and then you run this apply command, and then poof, everything just starts doing stuff. And we didn't have to really think too hard. Maybe there was some setup of a Kubernetes cluster somewhere, but I hand-waved over that a little bit. But for you as a consumer, or you writing your application containers, or you writing your Magento store containers, you wrote some declarative YAML files and applied it, and you were basically running in a production environment. You saw that there were a lot of settings, and then it was easy, right? As I said, I ran one single command. But if you're doing Magento deployments, if you're an agency and you're doing a lot of these things, does it scale across multiple clients, right? So can you run multiple flavors of eCommerce store? So maybe you have a store, maybe let's consider the single merchant example. You're one merchant, but you run in a bunch of different regions. Maybe you have stores that are located in Southeast Asia, maybe you have stores that are located in the US, but you want to have the same deployment structure for each store in each region, but you need like different hardware constraints. So maybe your Southeast Asia store gets significantly less traffic than the other stores. So maybe you do a smaller deployment there. And then maybe in the US, you have much larger stores, so you do a much bigger deployment there. Kubernetes itself handles that. However, it's not for a developer quite easy to specify, and repeat that process. So that leads me to the next CNCF project called Helm. Helm was originally started by a team. The Helm team was actually eventually acquired by Microsoft, but Helm is the Kubernetes package manager. So instead of just deploying, arbitrary YAML files, you can create templatized files that allow you to specify a application set and then scale it onto any Kubernetes deployment that you'd like. So if you want to do, if you want to repeat your deployment on multiple clusters, you can. Or even if you wanted to repeat the same deployment on the same cluster, but in kind of two different forms, you can do that too. These packages, if you're familiar with the Rust ecosystem, we call them crates, but in Helm, they're called charts. So a package is a chart, or an NPM package if you're in the Node ecosystem, or in Composer in PHP, because we're PHP here. You have PHP packages. In Helm, they're just called charts. Charts are semver, so they are versioned semantically, 3.0.0, 4.0.0, et cetera, et cetera. And then you, the chart author, define the API of your chart. So you may have noticed in the last, in my example, there were a lot of different settings, right? You can specify the container port, you specify some labels, you give some names. That's a lot of settings. And if you're a chart author, or if you're someone who's providing your chart to your teams, you want to maybe minimize or control the number of settings that your teams have access to tweak, because who doesn't like very simple APIs? You, the chart author, control that. And then ultimately, the really cool thing is that it's a package ecosystem, dependencies of dependencies of dependencies of dependencies. Charts can depend upon other charts. So if you are building Magento, you can imagine maybe there's a Rabbit chart, or maybe there's an Elasticsearch chart that I can just use. I don't actually have to think about it so much. And the answer is yes, those things exist. Actually, the same thing exists with OpenSearch as well. So major subdependencies of the service versions of Magento have available charts. Just to showcase a little command here, if you wanted to use Helm as a CLI tool, you can see an example there. So now we're going to basically take that same application that I did with kubectl, and we're going to do it with Helm. So if we want to switch back to my the other monitor. Oh, sweet. Are we there? Yeah, awesome. Okay. So real quick, I'm just going to clear out all the resources that I had from that last deployment. So we just did the kubectl apply from the last thing. I'm going to delete those out. We'll see those go away. And then once those have gone, we will start to do the Helm deployment. And I'll showcase that. So let's just delete this other pod here. We don't want it. Go away. All right, it's gone, I think. Yes, sweet. So no more resources, completely fresh environment, nothing to worry about there. So I'm going to come over here, and I'm going to showcase basically the same thing. This is a Helm chart. It's just a demo chart, and it has essentially the same setup. So we're deploying this same PHP Apache application. It's going to respond OK. We have a horizontal pod autoscaler, same kind of setup. Then we have that same service. So I'm going to change some directories around just to go over to this Helm directory. I happen to have a nicely saved command that I would like to run to install the chart. And instead of running kubectl apply, I'm going to run Helm upgrade install, and I'm going to give it a path, and I'm going to give it a release name. So in this case, I'm installing the Meet Magento Florida 2023 application. I have some nice ASCII art, because why not? And we'll be off to the races. So same kind of setup. Essentially, we're deploying the same resources, but with a Helm chart instead of just a kubectl apply. And you can see the same kind of thing. I have another pod, does the same kind of thing, and I'm going to do essentially the same concept. I'm going to apply load. So same idea, basically just run wget and run it a lot. And if we're very lucky, it's going to do the same thing. We'll see the pods start to scale up. But I'm doing the same thing I did before, but importantly, what I'm about to show is the next features that you get with Helm. So Helm allows you to, for you, the chart author, to specify the API of your application. All right, so this is scaling up, it's doing its thing. So I'm going to do the same idea, watch, kubectl, get pods, and if we're very lucky, we'll start to see this scale up in the same kind of way. While that's scaling, I'm going to showcase the features of Helm. So you can see it start to scaling up in the background. So Helm allows you to specify, as I said, you specify your own API. So maybe like you're a chart author and you want to specify some auto scale settings. So maybe for your region, or your deployment in Southeast Asia, maybe your min instances is 1, and maybe max instances is 3, right? So you're going to specify that. For you as the chart author, you can say, okay, well, in my horizontal pod autoscaler, I want to use those values here. So you can do .values, .autoscaler. Let me just make sure I named that correctly. Autoscale, not autoscaler. In instances. And the same thing on the other side. Maybe max instances, like that. Just like that. And essentially, this is the API you specify for your users who want to use your chart. Basically, it looks like that. And I'm going to stop that from running. I don't want to apply any more load, but you saw it scale up in the background. You can specify and say, back to that command here, like this. Please only use my min instances 3, max instances, just to get the horizontal pod autoscaler. It looks like this. But you can see min pods, max pods. I can control how many instances of the application I run at any given moment in time, and I can specify what that high-low is. So finally, this is a lot of cool stuff. If we want to switch back to the slides one more time, what does any of this have to do with Magento, right? Because I just showed you a bunch of stuff that doesn't include Magento in the name. So one more time, if we switch back to my desktop, we're going to show you what a Magento cluster could look like. So importantly, I'm going to grab the command. I already have this set up, so we're not going to wait for any setup. Just going to switch my namespace out of the MFL namespace to my default namespace. And look at this. So when you're running Magento, you can do a lot of crazy things. So Helm and Kubernetes afford you a lot of opportunities. So for example, you can run the cron stuff in a pod in the background. Kubernetes has a cron scheduler built into it. So if you want to run the cron jobs across 100 different servers and you just want it to allocate to whichever server happens to be available at that moment in time, you can do that. If you want to run 100 copies, so I'll just give you an example of this, of the actual Magento app, you can do that, right? So you can run as many instances of Magento that you want. So if you have Black Friday and you need to handle load and you need to handle it on the fly and you don't want to have some dev going in setting up 100 servers, you can do that. The other things that are cool in here, you can do, so for example, if you're using RabbitMQ, you probably have queue consumers, right? So you have message queues. Some people will run them in cron. I would not recommend it, but you can. However, with Kubernetes, you can split this across all of the servers. So if you wanted to run your consumers constantly, so that if a new message comes in and you want it to be processed as soon as possible, you can do that. And you can do it across as many servers as you want. And you can allocate it to whichever server happens to be available. Importantly, if you see on my screen, there's some of it that say error. Kubernetes will handle if the pod crashes. and it'll just spin up a new pod in a container for you. So it's self-healing. So not only does it auto-scale, it also self-heals. There are all sorts of other cool stuff that you can do. Like you can put the underlying services that you use, if you use Elasticsearch, OpenSearch, et cetera, you can put them into high availability mode so that, you know, if those go down, you can spin up another one, so on and so forth. That is it. So I will leave the floor to questions if anyone has any questions.
With your Kubernetes setup like this, where do you put the varnish?
Yeah, so Varnish is actually in cluster. So here I have a little Varnish instance. You can spin up as many of them as you want. But yeah, it's in the cluster. But it doesn't have to be. You could very easily take it out of the cluster if you want to do it at the edge. Like if you wanted to use Fastly or if you wanted to use, yeah.
So I've often found, like, for example, with EC2, like the default instance you get needs to have tweaks done to it on the fly, like the international library or Sodium or whatnot. I mean, how do you generate the server image that's used here?
Yeah, so importantly, so I'm just show you another thing here. So K's get nodes. You can specify different kinds of nodes. So if you need a node that has special configurations, so the very first thing is you have an abstraction layer with a container. So if you need specific Linux binaries in that container, you can put them in and ship them in that container. However, if there are other things, for example, like Elasticsearch, there's a, in sysctl, there's a VM max map count that needs to be set to some higher value. You can specify, please run Elasticsearch only on the nodes that have this underlying Linux kernel level setting. And you can specify different kinds of nodes. So if you need nodes that have high memory and that setting, you can do that. And there's something called taints and tolerances in the Kubernetes API for doing that. But importantly, if you're writing a chart, you can do that all yourself, and you don't have to hand that off to all the developers who use the chart.
Question. Anybody? Okay, so then let us thank Damien for his presentation.